In today's video, I'm going to review with you properties and changes in matter. In science, we use properties of matter to describe the matter that we see, the matter that we come across. Chemistry is all about the changes. Chemistry is about understanding what causes matter to change and how it changes. So both of these are very important to us. We're going to start with the properties. Properties are just descriptions of matter. If you can describe matter, you can give me properties. There are two types. One that we're very familiar with, the physical properties. One that we're not so familiar with, those being the chemical properties. Both have equal importance to us. Let's start with the physical properties. A physical property is what you observe with your senses or a tool. Using your eyes, your sense of touch, smell, taste, not so often in chemistry, but in some cases taste, our sense of hearing, or anything we use a measuring device to gather. A meter stick, balance, a scale, graduated cylinders, anything we use a tool to gather is most likely a physical property. The key in identifying them is to ask yourself, what do you have when your change is done? If you're looking at a physical property, you still have the same substance that you started with. Physical properties can be observed without changing what the object is made of. So if I talk about a piece of paper, this piece of paper is white, it's got black typing on it, it's got pencil marks on it. All of those are physical properties, and I know they're physical properties because it's still a piece of paper. I haven't changed what it was made out of. Chemical properties are quite different. And we're not too used to doing chemical properties or making chemical-based observations. A chemical property describes how the substance reacts. We're no longer describing the object itself. We're no longer describing the piece of paper. What we're describing is how that substance interacts with other substances. The key to identifying them, they're quite the opposite of the physical properties. If you want to observe a chemical property, you'll have to turn that substance into something else. You'll have to make something new when you observe it. These are some examples of both physical and chemical properties. And again, the physical properties are the kind of things that we do with our senses or tools. Color is something we do with our sense of sight. Shape is something we can do with our sense of sight or touch. Texture is something we do with our sense of touch. If I say the meter stick is rectangular, I looked at it to see that. If I say it's smooth, I've used my sense of touch to describe the texture to you. The meter stick is 1 meter long. Length is a physical property. I haven't changed what it's made of. It's still a piece of wood. In all of these, when we make our observation, we're going to still have the same substance that we did when we started. Chemical properties include things like flammable. Simply means it burns. Corrosive. When something is corrosive, it eats away at other substances. Oxidizer. That means it produces oxygen. Provides a source of oxygen. Explosive is like flammable. Reacts with oxygen in the same way that flammable does, but does it so quickly it produces a shock wave. And then one that's very often overlooked, stable. Stable means it does not react or interact with other substances. I've got to learn to look at this meter stick and say wood is flammable. It will react with oxygen in a means that produces light and heat. I could also say it's relatively stable. This meter stick is who knows how old. It's been around for a long time because wood is a stable substance. In both cases, I'm describing how it reacts or interacts with other substances. If I wanted to observe flammable, I'd actually have to burn it, and it wouldn't be made of wood anymore. I'd change its substance. Another example, talk about sodium metal. Talked about it in the class a few times. We talked about compounds. Sodium is silver. It's soft. You can cut it with a butter knife. It has a very low melting point for a metal, somewhere just over 200 degrees Fahrenheit. All of these are physical properties. All of these could be observed without turning it into something new. It would still be sodium. Chemically speaking, it reacts vigorously with water. put it in water, it bursts into flames, and put enough in water, it'll explode. If that happens, you no longer have sodium. It reacts with chlorine to make sodium chloride, what we call table salt. Again, if I want to see this happen, I wouldn't have sodium anymore. I'd have sodium chloride. I'd be making something new in order to observe both those chemical properties. Moving on to the changes in matter. There are two types of changes, chemical and physical, just like we talked about with the properties. We have the same two types. And again, the difference is very similar. It deals with composition. It deals with what it's made of. You can observe a physical property without changing what it's made of. A physical change will not change what it's made of. Same idea. For a chemical property, to observe a chemical property, you have to change what it's made of. In a chemical change, it will change what it's made of. Same concept. We'll start with the physical changes. A physical change is a change in one or more physical properties. It's a change in how we describe the object. If it's a purely physical change, your substances will stay the same. The composition of the matter will stay the same. As an example, we could talk about painting a fence. When I start, I have paint and a fence. When I'm done, I have paint on the fence. It's still the same two substances. They're still made out of the same things. This is latex. It's plastic. That's wood. When I'm done, I've got the plastic on the wood. They're still the same two things. I haven't changed what they're made of. Because I'm still dealing with the same substances, I would call this a physical change. Other examples of physical change include cutting a piece of paper. If I take a piece of paper, cut it or rip it, it's still paper. I haven't changed what it's made out of. That's how I know that that is a physical change. Sanding a block of wood. It's still wood when I'm done. All the little pieces of dust that come off are wood. I'm not changing what it's made of. It's a physical change. This one's difficult for some students. Melting a piece of ice. We ask ourselves, what is the ice cube made out of? And the answer is water. What's the puddle that's left on the counter made of? Water. I haven't changed what it's made out of. Melting, any state change for that matter, is a physical change. Chemical change is a change in the composition, a change in what it's made out of. When a chemical change is done, you no longer have the same substance. You have something totally different. Example I've got up here is burning wood. We start off with wood and oxygen. When we're done, when the fire's over, we don't have wood and oxygen anymore. The black stuff that's left behind is mostly the element carbon. What goes off into the air is carbon dioxide and water. We started off with wood, which is mostly a compound called cellulose. We've combined it with oxygen, and now we have something totally different. Carbon, water, and carbon dioxide. New substances were formed. That's how I know it's a chemical change. Other examples include iron rusting. You start off with iron and oxygen. You end with something called iron oxide or rust, a different substance, a new substance. Acid eating away at a piece of metal. This is that corrosive idea. Acids are corrosive. When you put them on metals, they eat holes in the metal. The metal is no longer that pure substance anymore. It's no longer that element anymore. It gets changed into something different, something new. Digesting food. A lot of students miss this one. And I always ask the same question. Is what comes out the same as what goes in? The answer is a clear no. It's not the same. We're making something new. That's how we know it's a chemical change. Again, if you have any questions or concerns or problems with properties or changes in matter, make sure that you put your messages on the wall or ask sometime in class.